Hello everyone. In this video, we're going to discuss the third part of the inequalities, and that is the linear inequalities in one variable. This lesson is very similar to linear equations in one variable. Recall that a linear equation is made up of two expressions connected by an equal sign, while in linear inequality, our two expressions are connected by the inequality symbols. So what is linear inequality? An inequality which can be written in one of the following forms. We have ax plus b less than 0, ax plus b greater than 0, ax plus b less than or equal to 0, and ax plus b greater than or equal to 0, where a and b are real numbers and a is not equal to 0 is called a linear inequality. To solve the linear inequalities in one variable systematically, we have to understand and follow a set of steps. So the first step is to simplify each side of the inequality. Second, collect variable terms on one side and constant terms on the other side, then simplify again each side of the inequality. Third, isolate the variable and solve by dividing both sides of the inequality by the coefficient of the variable term. And lastly, express the solution set in set builder notation or interval notation and graph the set on the real number line. Observe that our steps in solving linear inequalities in one variable is very identical in solving linear equations in one variable. Sa linear equations in one variable, nag-consider lang tag-usa ka solution, while here in linear inequalities in one variable, we consider many solutions. Now, let's have an example. Find and sketch the graph of the solution set of each of the following inequalities. Number 1, we have positive 4x minus 5 less than 11. So to solve this given inequality, we just need to apply the steps in solving linear inequalities in one variable. So the first step is to simplify each side of the inequality. And observe that our given inequality is already in simplified form, so we can directly skip step 1. So our next step is to collect variable terms on one side and constant terms on the other side. Then simplify again each side of the inequality. Our simplified given inequality is positive 4x minus 5 less than 11. Before collecting variable terms and constant terms, we have to identify first which terms are constant and which terms are connected by a variable. In this case, it is clear that negative 5 and positive 11 are constant terms and positive 4x is a variable term. So to do this, we will collect the variable terms on the left side and constant terms on the right side. So basically, mag-add lang tag positive 5 both sides of the inequality, then we obtain positive 4x less than 11 plus 5. Simplifying, we have positive 4x less than 16. Moving on to step 3, we have to isolate the variable and solve by dividing both sides of the inequality by the coefficient of the variable term. Our obtained inequality in step 2 is positive 4x less than 16. And observe that the coefficient of our variable x is positive 4. We divide both sides of the inequality by 4. Then we have positive 4x divided 4 less than 16 divided 4. Simplifying, we obtain the solution set of our given inequality, and that is x is less than 4. Finally, we have to express the solution set in set builder notation or interval notation and graph the set on the real number line. Therefore, the solution set in set builder notation, we have x is in R such that x is less than 4, and it is equivalent to an open interval from negative infinity to positive 4. To graph this on the real number line, mag-draw lang tag solid line ranging from negative infinity to positive 4, and it should be enclosed a parenthesis symbol indicating that 4 is not included in our solution set. So, let's have another example. So number 2 example, we have 2 times 2z minus 5 plus 7 times 2 minus 2z greater than or equal to 0. So similar sa example number 1, we will also apply the steps in solving linear inequalities in one variable. So step 1, we have to simplify each side of the inequality. So since the given inequality on the left side is not in simplified form, so we can simplify it by applying the distributive property of multiplication over addition. So we have 2 times 2z, that is 4z, 2 times negative 5, that is negative 10, plus 7 times 2, that is positive 14, and 7 times negative 2z, that is negative 14z, and this is greater than or equal to 0. So combining like terms, we have 4z minus 14z, that is negative 10z, and negative 10 plus 14, that is positive 4, and this is greater than or equal to 0. So our given inequality is now equivalent to 4 minus 10z greater than or equal to 0. Our next step is to collect variable terms on one side and constant terms on the other side. Then simplify again each side of the inequality. So usually, we collect the variable terms on the left side and constant terms on the right side. So basically, mag-add lang tag negative 4 both sides of the inequality. Then we obtain negative 10z greater than or equal to negative 4. So moving on to step 3, isolate the variable and solve by dividing both sides of the inequality by the coefficient of the variable term. So our obtained inequality in step 2 is negative 10z greater than or equal to positive 4, and observe that the coefficient of our variable c is negative 10, so we divide both sides of the inequality by negative 10. And always remember that when dividing or multiplying the inequality by a negative number, it will make the inequality symbol reverses. So from greater than or equal, nahimo siyang less than or equal. And if our given inequality symbol is less than or equal, so mahimo na po siyang greater than or equal. So in this particular example, we have negative 10z over negative 10 less than or equal to negative 4 over negative 10. So simplifying, we obtain the solution set of our given inequality, and that is z less than or equal to 2 over 5. So the final step is to express the solution set in set builder notation or interval notation and graph the set on the real number line. So therefore, the solution set in set builder notation, we have z is in R such that c is less than or equal to 2 over 5. And this is equivalent to a half open interval from negative infinity to 2 over 5. So to graph this on the real number line, mag-draw lang ta og solid line from negative infinity to 2 over 5, and it should be enclosed a bracket symbol indicating that 2 over 5 is included in our solution set. So that's it for our linear inequalities in one variable. So see you on the next lesson.